Welcome to the ADOxx webinar about the assembly instructions for an mBot. Hello, my name is Anna Summerida. I am a member of the ADOxx.org team as well as a business informatics student at the University of Vienna. For your information, all microphones are muted. So if you have any questions, please type them into the chat window. Let's start with a short agenda. First, I will give a short introduction about what are mBots and what it is about. Secondly, I will talk about assembly instructions. This chapter is divided in components and tools, setup overview, the real assembly, a basic configuration, and a first mBot test. Afterwards, a short summary and an outlook will be given. Last but not least, we have time for questions and answers. Let's start with the introduction. What are mBots? mBots are small cars from Makeblock. They are robot kits for education and hands-on programming experience. They are also used for research purposes and simulation. We use mBots to simulate real-world scenarios. Therefore, we establish connection to models, which then enable model execution. How do we do that? We use the basic construction manual from mBlock. Afterwards, we configure some of additional sensors, a Raspberry Pi and a power bank. Components and tools. What do we need? We need the mBlock basic version. This is a kit consisting of the mBot, a line following and a distance sensor, as well as a Bluetooth manual, screwdrivers, and some additional packages. Furthermore, we need 4 rechargeable AA batteries, as well as a battery charger. We also need Raspberry Pi components. We use the Raspberry Pi Model 3B, as well as a camera module, a Lego Pi box, and a lithium power pack for the Raspberry. Moreover, we also use some additional Makeblock components. These are a LED matrix, some hardware components, a hardware pack, and some additional cables. For fixing the Raspberry on the mBot, we use some cable ties. Here you can see an overview about the setup. You can see the hardware beams, the Raspberry Pi as well as the Raspberry Pi box, the M-Core board which is included in the Makeblock kit, as well as batteries and cases. Then you can see the power pack for the Raspberry. You can see the line following sensor, the distance sensor, the LED matrix, as well as a camera module for the Raspberry Pi. For the assembly, we use some parts of the original Makeblock assembly instructions. In order to be able to assemble all parts, it is suggested to unpack all elements and order them on an empty table, and you have to be careful that no screws or different sizes are mixed or lost. The first steps are from the assembly instruction document, which is provided by Makeblock, and afterwards some of our suggestions and some of our specific setup instructions are given. As we have some special requirements, we decided to adopt and extend the basic construction manual in order to make it able to have a connection to the Raspberry Pi, as well as additional sensors and modules. Okay, we start with the basic assembly instructions. The car chassis is combined to the motor and the wheels. These steps are straightforward, so I think I do not have to explain them in more detail. Furthermore, we assemble the front mini wheel at the bottom of the car, which is also connecting the line following sensor to the car at the bottom. Afterwards, we build the frame for the additional modules by connecting some additional hardware beams with the screws and nuts like on the picture, and I will show you how this looks by using a webcam. You can see here line following sensor, the LED matrix and the distance sensor, and they are all combined with the hardware beams here, which is the blue frame. We used 4 beams as well as 4 screws and nuts to connect the frame. The next step is then to provide some holding construction for the M-Core board, which is also delivered in the mBot kit. And therefore, we decided to connect 2 beams for each side, so all in all 4 beams. And we use long brass studs as well as screws and nuts to connect them. And afterwards they are connected to the car. And you can see that here we have the 2 beams as well as the brass studs, and the beams are connected by using screws, and the brass studs connect the beams with the car chassis. The next step is to fix the battery pack to the car, and therefore also brass studs and screws were used, but the brass studs are a little bit smaller than the other ones which we used before. The next step is to connect the battery case to the M-Core board. The M-Core board is delivered in the M-Core board as well as the battery case are delivered in the mBot kit. And this can be done by using a hoop and loop fastener. You can see as well on the picture. Afterwards, the M-Core board is connected to the beams we assembled before, and this is done by using 4 long brass studs and 8 screws. After connecting the M-Core board, also the battery case can be put on the bottom of the board. The next step is then to connect the lid matrix with the frame. This is done by screws and nuts, as well as the lid matrix are combined with the frame, and the car. You can see that here. And then also the distance sensor is combined with the frame, and you can see that here. Afterwards, the Raspberry Pi camera module and the Raspberry Pi are connected, and this can be done by threading it through the top part of the Pi box because there is a cutout. Then the Raspberry is inserted into the Pi box. You should have a look that the cutouts suit to the Pi box. Afterwards, the Raspberry is placed on the mCore board and fixed with the cable tie so that everything is working and fixed, and we will have a look. You can see here the Pi box, the mCore board, the cable tie for connecting the two of them. The camera goes from the front of the Pi box to the self-made frame, and this can also be combined with some cable ties to fix them. Afterwards, the basic assembly is finished, and we will go to the cables. First, we connect the sensor cables, which are RJ25 cables. These are connected to the line following sensor, the distance sensor, and the LED matrix. We connected them to port 1, 2, and 3 because our program works like this, but this can also be adjusted. And the motor cables are combined to the M1 and the M2 slot of the mCore board. Afterwards, the battery cables can be combined. The first one is going from the Raspberry Pi to the power bank. This is a micro USB to a USB connector. And the second battery cable is going from the battery case to the mCore board. The mCore board can also be connected with the provided USB cable to the computer or the Raspberry Pi. Let's have a look. You can see here the cables for the sensor, and here the battery cable for Raspberry Pi and the Raspberry Pi pack. This is the connector to the computer or to the Raspberry Pi. Here you can see the motor cables for M1 and M2. Okay, then the first basic configuration is working with mBlock. This is the provided software by Makeblock, and you have to use the mBlock 3 for PC. You can download and install the software and open it. It looks like the picture, and some basic preparations have to be done in order to make the mBot driving. The first one is you go to the tab Extensions and choose Makeblock. Afterwards, you have to go to the tab Boards and choose mBot mCore. Thirdly, we have to go to the tab Connect and install the driver with Install Arduino driver. This has to be done only once. Afterwards, we can have a look at Connect and Serial port for the available COM ports. And then we are ready to plug in the cable from the mBot kit to mCore board and PC. Then we can again go to the Connect tab and choose Serial port. And the port that appeared after connecting mBot and PC is relevant. So you can choose this port. And after connecting the PC and the mBot, you can again go to the tab Connect and choose Upgrade Firmware. This is the first basic step. And this is how the software looks like. Here you have the tabs, Connect and Board are very important. And then you can make a simple project by dragging and dropping some parts together. By double-clicking on the program, you can start it. And this is a very simple form of testing the mBot. And this is also very good for looking if the sensors are working correctly or if there are any problems. Be careful that if you are testing the driving function, that the mBot doesn't fall from the table, because the cable for connecting the mBot and the PC isn't very long and this might lead to problems. So it might be reasonable to place the mBot on a box so that the wheels can turn without actual driving. If you want to have advanced functionalities and programs, you can use the Raspberry Pi, which we also do. And this uses a web service running on a Tomcat in order to operate the mBot. Let's have a short outlook and a short summary. We use a web service on the Raspberry Pi as we require some advanced functionalities. Basic reason for the usage of mBots is as we want to simulate real-world scenarios, and this is done by using a web service within ADOxx models by sending HTTP requests. You can have a look at the ADOxx.org page, which also gives further information on HTTP requests details. And now we have a short look at the mBot driving. I turned it on and I connect with the IP address, the port for the Tomcat which is installed on the mBot, and our customized URL. Then we wrote a controller, and here you can see the Raspberry Pi camera picture, and in the background you can see the BOC laboratory. We can now try to use the functionalities. Here you can also see that the mBot is moving with speed 100 and that the moving time is 2 seconds. You can drive forward and backward, as well as left and right. And for left and right, only one of the two motors is turned on. So that was our webinar. I would like to thank you for your attentions, and I would like to ask you if you have any questions or you need answers. In case you have questions after the webinar, you can contact us at info@ADOxx.org, or you can also like us on Facebook, follow us on Twitter, or join us on LinkedIn. And you can also make an appointment if you would like to have a look at the BOC lab at your own. Thank you very much.